Okay, here's my second example, the third video. I'm not going to write out the steps, just do the problem. All right. And this one is going to be a weak base with a strong acid. My weak base in this case is ammonia, and my strong acid is hydrochloric acid. They have the same molarities. First step is boom, boom, do the dilution. And here is, and my end volume for both of them is 35. So add these up, divide it by the molarity, or to multiply these and divide by the new volume, and I get this for both. All right, so I'm starting with more base than I am acid, so that should affect things. And the next thing I need to do is write my net ionic equation. This is a tricky one. Ammonia doesn't dissociate. HCl dissociates into H and Cl, and you get this is our net ionic equation. Cl drops out on both sides because you make this in chloride and then it drops out. All right, so I'm going to do my stoichiometry now. And remember, I'm using one-to-one relationships for any weak acid or strong base. And in this case, I have a weak base and strong acid. So I'm just going to assume a one-to-one cancellation. All right, so this is going to go here and that's going to go there. I'm not starting with any of this. This is going to subtract from that and then make as much of that as it is subtracted. All right, and this should be plus. I'm left with this concentration of ammonia and that a concentration of ammonium. All right, and now I would take these things and plug them into my equilibrium expression, or before I do that, my Rice table. And my Rice table, I don't use my net ionic equation. I use the equation for this in equilibrium. That's the one involving water. So that's that plus water. This is going to be a base, so it's going to accept a proton and turn the H2O into OH. All right, like that. And then I substitute these values into the equation. So this goes here, and that's going to go there. All right. I don't have any hydroxide at this moment. All right. Now, since this isn't a Rice table or an ice table, and I didn't write it in, I'm going to be left with that. All right. This is going to go up. That's going to go down. I like this problem because you need a Kb value for ammonium. You're going to use the Kb equation for ammonia. All right. This value is going to go there, and that value is going to go there, and that's going to go there. And once again, we're going to neglect the x. And the Kb you're going to get from would be given to you, that you wouldn't have to know that. All right. So that's what it's going to look like after substitution. All right. And then these would fall out of the equation, and I'd multiply this times this, and I'm left with that. And then I'm going to divide both sides by 0.043, and I'm going to get that, 5.736. Now, this is a pKb, so I'm solving for the concentration of hydroxide. To get pH, I could do different things. I like to take the POH personally. My middle name is Ophelia, so that's why I like to do it. And POH is the negative log of the concentration of OH, so I just plug that in. It's already in my calculator, and I get my POH is 5.24. And then remember, POH is the same as pH. No, not the same. Added is equal to 14, and so you just minus this number in the calculator, minus 14, and just remember it's not a negative. And that my pH is about 8.79. All right.